Okay, here we go again. We're going to cover quantitative data and their displays. The types of graphs that we can use to display quantitative data are dot plots, stem and leaf plots, and histograms. Time to go over dot plots formally. A dot plot shows each data value as a dot placed above its location on a number line. Here are 18 data points for the federal funds rate for long run in September 2024 expressed as the percentages. What we end up doing is taking each one of these values, putting it on a horizontal axis, and indicate that value. Here we have three 2.5, so we indicate three dots or points right on top of each other to indicate that there's three values of 2.5%. And we repeat this process for all of our data. And this creates our dot plot. In general, when we're making our dot plot, we're going to follow three steps. In our first step, what we want to do is draw and label our horizontal x-axis. In this situation, we're labeling what each of the data points represent, which is federal funds rate as a percent. In the second step, what we want to do is have a reasonable scale for our dot plot. What we consider to be reasonable is there's at least an interval value that is smaller than any of the actual dots, and a interval value that is larger than any of the actual data dots to be plotted. And in the third step, we just plot the data value based on our constructed intervals. There's also a video how we can create a dot plot using Excel and the COUNTIF function. Time to make a dot plot in Excel. Here's the end result of more or less what we want our dot plot to look like. However, if we grabbed our data and insert our dot plot, it doesn't look like anything we want. It just looks like individual data points. So what's missing is the proper count of each of the data. Here, we can see that there is one count of 2.125. Then there's a total of three counts of 2.5. That is appropriately stacked one on top of each other, followed by another one count. Then we have another three count. However, it is 2.75, all stacked on top of each other. And it continues this process, and our data is appropriately stacked on top of each other, keeping track of all the counts. We're going to have to use the COUNTIF function. Let's figure out what it's trying to tell us. The first set of values before the colon is telling us what cell to start our count on. A represents the column and 3 represents the row. We're going to end up using these dollar signs to fix our position so that they don't change. The second value after the colon will also have a dollar sign because we want to keep our count. And the second value represents the rest of the range to continue our count. The last value here tell us what the criteria is, meaning it will indicate what the count is. Let's do one together. We're going to arbitrarily enter in some data. It does not matter if the information is in order, because the COUNTIF function does not care about that. It will calculate it properly for us. If we want to just make sure it is calculating it properly, we'll just keep an eye on the number of ones we have. So in order to enter our COUNTIF function, we're going to hit equal sign, type in COUNTIF, or click on the function command that comes up. We're going to hit $A to represent the column. Then we're going to hit $3 for the row. Then we're going to hit colon and then $A3, okay, so that we are in the correct cell. That'll be for the ending of our range. And then our criteria, we hit comma, and then we're going to hit A3 to keep track of the count. We're going to close our parentheses. We're going to copy our cell, select all of them that we want to paste over, and there you go. As we can see, the number of ones are being properly counted to 4. We're just going to select our information, insert our data, and there we go. We have our dot plot. Typically, we don't want the vertical column, so we'll just delete that. We'll delete the bottom, and then if we want to have different axes, we'll just go on the layout and then just add them in as we need them. Our dot plot is stacking up the values accordingly. There's all of our 4 ones. We're going to have 2 2s, 1 2. We have no 3s. We have 2 4s. There it is, 1 4, 2 4. We have our 2 5s. There's our first 5, our second 5, and our single 7. And everything else is just be altered to whatever we want. We can label our horizontal axis as data and our vertical axis as count. If we feel like it, we can also add in a title. Let's talk about a stem and leaf plot, sometimes just called a stem plot. A stem plot shows each data value separated into 2 parts. A stem, which consists of all but the final digit, and a leaf, which is the final digit. The stem are ordered from lowest to highest and arranged in vertical columns. The leaves are arranged in increasing order, extending out from the appropriate stems. Example time. Let's consider the following data from Olympics.com. The gold and silver medal for men individual archers based on points scored at the 2024 Paris Olympics. We have a South Korean athlete and a United States athlete. The South Korean athlete got 27, 28, 27, 29, 30, and the United States athlete got 29, 24, 29, 27, and 30. So we're going to take this data and make our stem and leaf plot. So we're going to focus our stem and leaf plot on the South Korean athlete. First thing we want to do is make our stem. That will have 1 for the 10s, 11, 12s, 13s, etc. And we have our 2s here to represent the 27s, the 28s, and 29s. We have our 3 here to represent 30s, 31s, and any other 30 values. In our second step, we'll add in the leaves. Since we have no 10s, 11s, 12s, and 13, we're going to leave this part of the leaf blank. Then we add in a 7 to represent our first 27. We'll space some out and put in another 7 to represent 27 again. We have our 8 to represent 28, a 9 on the leaf side to represent 29. And to finish it off for 30, we'll just put a 0 on the leaf side. Part 3 here, we want to make sure everything is in a proper order. We're going from least to greatest vertically and least to greatest horizontally. Lastly, we need to make sure we add in a key to make sense of what the stem represents, in this case, our 10 values, and what our leaf represents, in this case, our 1s. So we write the word key. We'll have a 2 to represent our 20s. We'll have a right side bar to separate between the stem and the leaf. We'll include a 5 to represent for the value 25. The key does not actually have to include any value in our data set. And here's how we can construct a basic stem and leaf plot. We'll also go over how we make a stem and leaf plot on Excel for the United States athlete. There's some good news and bad news. The bad news is that there's no nice, easy shortcut for us using one of these insert graphs or plots. The good news is that we're going to just power through it and get our stem and leaf plot done for the data collected on the United States individual. We're going to first start by labeling where we're going to have our stem values. Then we're going to label where we're going to have our leaf values. So notice that they are starting to overlap each other. What we can do is select a few cells and do a merger so that they have enough space for themselves. Underneath the stem, we're going to enter the values for our tens. We're going to have 1 to represent tens. In this situation, we have no 10, 11, 12s, or 13s, etc. However, we have some 20s, and we'll see that we'll have some 30s. The great thing about Excel, though, we can easily rearrange these from least to greatest. So now that everything is nicely rearranged, we can fill in the leaves section more easily. Since there's no teen values, we're going to leave this here blank. This is totally optional. If we wanted to, we can delete this entire row. In the 20s, though, we're going to start off putting a 4 to represent 24. We're going to put a 7 to represent 27, a 9 for 29, a 9 again for another 29, and then for 30, we'll put in a 0. Now we want each of the values to be next to each other. What we can do here is click on the top and on the right side so that each of the columns are the appropriate size. Notice that this one here, when we enter the word leaf, is too wide. So we can just drag and resize it as we need it to be. And then we're going to click again here on the right, and there we go. All of our leaves are appropriately sized. We can highlight where we want to put in the lines. Just pull up the border and then add a border. So there's our border line. And on the right of the stem, we would like to have a border. So we just add in a right border. And there we go. The next thing to do is to add in a key. So we type in key. We're going to type in the value. Again, we're going to also want to add in a right border. Then we're going to type in another number. So 2 and 4 here representing 24. I'm going to write in equals 24. However, the issue here is that they're thinking we're writing an equation. So what we want to do is to highlight the area. We want to enter the equal sign, and we're going to convert it to text. Now that this is text, let's write it again so that it is now equals 24. And there you go, there's our equal sign. So we'll do a merger of cells to give it the space we need. One last thing to do is put a title on top. So we'll cut and paste our title. It doesn't quite fit again. In order to make it fit nicely, we're going to do merging of cells again. And we're going to keep merging the cells until we get the size we want. And there you go. Here's our stem and leaf plot. We can just copy this and paste it wherever we want. In this situation, I would like to copy it and paste it into my PowerPoint presentation. So I've copied and pasted, and there you go. There's our stem and leaf plot. If I click to the side, all the extra little grids are gone. Everything else is just aesthetics to alter however we feel like. Ooh, we have an extra type of stem and leaf plot called a back-to-back stem and leaf plot. Two sets of data can be compared using a back-to-back stem and leaf plot. So two stem and leaf plots put side by side, joining them with a single stem. Now we're going to make a back-to-back stem and leaf plot. What we really end up doing is take one of our stem and leaf plots and the other one and kind of smash them together. Let's take our data set again. When making our back-to-back stem and leaf plot, it's going to be really similar to making a regular stem and leaf plot. We're going to have our stem, size it accordingly. we're going to have our teen values, our 20s, and our 30s. We'll center this to make it look nice. We're going to highlight our stem, add a right side border for the US archer to indicate their score. And then we're going to have a left border for the South Korean archer and have their score over there. We're going to merge some cells so that we can title the right-hand side for the US archer. Then we're going to enter its data. So there are no teens, so we don't need to worry about that. We're going to have 4 representing 24, 7 for 27, 9 for 29, 9 again for 29, and 0 for 30. Similarly, we're going to do that on the left side. We're going to merge these cells so that we can put the title on top. And then for the one here, since we have no teens, there's nothing to worry about. Then we want to indicate our 20s so that we first start with 27. So it will look like 72. Then we'll do 27 again. It'll look like 7 and 2. We'll have 8, looks like 8 and 2. And 9 indicates as 29. Then we have a last value for 30, and then we'll indicate that as a 0. What we need to do next is to add a key. We want to make sure we format the key as text. So on the left side, for the Korean archer, the key is going to look a little bit different than the right side key for the United States archer. We're going to type in key. Then we're going to have 9 and then a right border and then a 2. So this will equal 29. And then for our US archer, our key is going to be the standard way of writing it, 2. Then we add in a right border. Then we're going to add 7. This will equal 27. And there you go. That's our back-to-back stem and leaf plot. What we want to do now is highlight these cells. We can right-click it and copy it and then paste it wherever we want. One more thing, we should add a title. This looks nice. We can select all of our values for our back-to-back stem and leaf plot. Since we need a little bit more space, we'll cut and shift it down. Merge some cells together. Then we type in the title of our choice. So we can say 2024 archery points scored. We can now copy our back-to-back stem and leaf plot and paste it wherever we need. Going to be pasting it into our PowerPoint presentation. And the rest is just aesthetics. If we want to, we can select the cells we want to recenter them so they look a lot nicer. Will look something like this for both our Korean and United States athlete. Let's talk about histograms. A histogram shows each interval of values as a bar. The height of the bar represents the frequency or relative frequency of the value in each interval. Let's see what that means. We want to use a dot plot or a stem and leaf plot to display quantitative data, but both show every individual data point, which may make it hard to see patterns in large data sets. Grouping nearby values together gives us a clear picture and leads us to a new graph, the histogram. So what we're going to do is have dot plots or stem and leaf plots. Then we're going to convert them into essentially different types of bar graphs that is a histogram. But these bar graphs take intervals of value. Let's look at a dot plot that we're going to convert into a histogram. The dot plot shows the hip girth measurements for 507 adults who exercise regularly, with the measure ranging from 79 to 128 centimeters. Next, we're going to break up the data into groupings of equal size. To create a histogram, divide the variables into equal size bins. In this graph, each bin has a width of 5 centimeters. For example, 48 adults have hip measurements between 85 and 90. So we're dividing the histogram into equally sized bins or groupings of 5 centimeters. So between 75 and 80, this will be one of the groupings or bins containing one value. Between 80 and 85 would be our second bin containing a total of 11 values. Between 85 to 90 would be our third bin containing 48 values, as indicated in our example setup. However, we want to take a note on what about borderline values. For instance here, there are two values that are 85. Do they go into the second bin or do they go into the third bin? We'll end up moving these two values into the third bin. Let's go over the reason why. When creating our bin size of 5 centimeters, in reality, they're not clean integers. We actually have to decide where the cutoff values are. In this histogram setup, what we're actually including in the second bin here, the numbers from 80 all the way up to 84.99 to be classified into the second bin. So the next integer up at 85 will go all the way up to 89.99. This is similarly done for all the rest of the bins. In the foreground, it is not clear where these borderline values go. However, when we're actually creating the histogram, we will adjust our values for the bins in the background so that our histogram will look really clean. The real bin width 4.99 centimeters to include an appropriate cutoff. All of these in-between values will be moved into the next bin category or the next histogram bar. We typically state clean integer values just so it sounds nice. However, when creating our actual histogram using computers, we will adjust the appropriate decimal values to make it look nice instead of it sounding nice. Here we have both the dot plot and the completed histogram. Let's take a closer look at the third bar graph and the sixth bar graph. To form the third bar graph, we are taking all the values from 85 up to 90 and count all of these dots, which gives us a total of 48, and that creates our third bar of 48 individuals that has the hip girth between 85 and up to 90 centimeters, not including 90. Similarly, to create the sixth bar, we'll be taking all the values of 100 and we're going to include all the way up to 105, but not including 105 to create our bar graph, counting a total of 97. And we end up doing all of this for every single bin for our histogram. Notice that there are no values between 120 and 125. So we have no bar. Notice that there are single counts for values between 75 up to 80 and another single count from 125 up to 130. We still want to draw a very, very thin line to indicate the count of 1. So let's describe the histogram that was just created. This histogram displays bars. Each bar represents a bin of hip measurements. The height of each bar indicates the frequency or the number of individuals in the bin. For example, each bin has a width of 5 centimeters. Let's have a general guideline on how to create a histogram. Whenever we are given our data, we want to create a table. Once the table has been created, we're going to decide intervals for our bins. Depending on what the interval are, or depending on the bin size, it can actually change the way the graph looks. In the third step, we want to draw both our x and y axis, and we want to label them accordingly based on whatever set of data we're given. In the fourth step, we want to make sure the axes are to scale. We don't want to necessarily create misleading graphs. And in the fifth step, we just draw in the bars to the appropriate height. So we had the height of 1, 11, 48, 139, 150, 42, 97, 42, 15, 3, 0, and 1 again. And there's our histogram. And this is the basic overview of dot plots to histogram. In a future video, we'll focus on the second step, and we'll see that depending on what we choose our bin or our interval with, it'll drastically change how our histogram will look. And as a result, we can possibly draw different types of conclusions. But that's for next time. If you think you learned something, then consider liking and subscribing. Otherwise, time to get out of here. I'll see you next time.